In this video, we're going to introduce the notion of polar coordinates. So, polar coordinates. So, the polar coordinate system is another coordinate system besides the usual Cartesian coordinates with x and y. So, let me show you the setup. So, we have a point here, and I'm going to draw a line like this. And the endpoint of this line, we're going to call this point r theta. That's a polar coordinate. This here, this horizontal line, this is called the polar axis. Polar axis. And the angle here is theta. And this distance is r. So r, it's not just a distance, it's called a directed distance. And we'll do an example shortly so you see what I mean by directed. So r is a directed distance. And theta is a directed angle. So it's an angle, so it does have direction. So directed angle. And it's counterclockwise. So the default is counterclockwise. Let's do some simple examples of plotting points in polar coordinates so you see how exactly this works. So I'll just call it EX for example. Say we had the point 3 comma pi over 6. Let's plot this point. So here's one axis and here's our other axis. So the way I do it is, and there's different ways to do it, I always travel theta first. So I travel pi over 6, so maybe I'm here, this is pi over 6, and then r is 3, so boom, that's it. That's all you do. So again, you travel theta, so maybe it's there, it's a rough estimate of where pi over 6 is, and then r is 3, and it's positive, so you go out to that point. If instead we had negative 3 comma pi over 6, again it's the same thing, you first travel theta. So you first go pi over 6, so maybe we're here. There's our pi over 6. But r is negative, so you go the other way, and so that would be your point. So if r is positive, you go up to where the angle ends. If r is negative, you go the other way. Let's do a bunch more until you feel like maybe you get it. How about 2 comma pi over 2? So again, it's r comma theta. So first you travel pi over 2. So when you do that, that's going to put you here at pi over 2, right? Because this angle here is pi over 2 on the unit circle. So there's your pi over 2. And then you go 2. So here you are. So there's your point, and this distance here is 2. Let's do another one. Let's say it was negative 2 pi over 2. In this case, you would travel pi over 2. So here we are. Here's pi over 2. But it's negative 2, so you go the other way. So it would be here, and this distance here would be 2. So that would be your polar coordinate down here. Because first you travel pi over 2, and it's negative, so you go the other way. Whereas in this example up here, it was positive, and so you go the same way. Something interesting happens with polar coordinates. Watch this. Say it was 3 pi over 2. So if it's 3 pi over 2, again, you draw your axes. So first you travel 3 pi over 2. That's going to put us down here. And then you go 2. So we're here. So these polar coordinates are actually the same. So negative 2 pi over 2 and 3 pi over 2 give you the same polar coordinate, okay, every time. Let's do another one. Let's try 3 comma pi. So this first says you travel pi, so you would go this way over here like this. And then 3, so here you are, boom, 3. One more. Let's say we had negative 3 pi. So first you travel pi, so we're here. But then it's negative 3, so you go the other way, so now we're here. So it's opposite. So if it's positive, you go to where it is. If it's negative, you go the other way. I think that's it for this video on plotting coordinates and polar coordinates. In the videos that follow, we'll talk about converting between polar and rectangular and vice versa. That's it. In this video, we're going to talk about converting between polar coordinates and rectangular coordinates. So coordinate conversion. So we'll start by actually just briefly deriving the formulas. So here is the y-axis, and here is the x-axis. And then here we have a point which we'll call, say, x, y. And we'll draw a vector, or a line, starting at the origin, ending at x, y. This means that this distance here is y, and this distance here is x. This angle here, we'll call this theta, and this distance here will be r. And the goal is to convert this point xy into a point r comma theta. So we can use the triangle and what we know from trigonometry to come up with stuff. So remember, SOHCAHTOA. So sine of theta is opposite over hypotenuse. So the opposite here is y, and the hypotenuse is r. Cosine of theta is adjacent over hypotenuse. So the adjacent is x, and the hypotenuse is r. And tangent of theta is TOA, so it's OA, so it's opposite, which is y, over adjacent, which is x. And last but not least, we have the great theorem of Pythagoras, which says that r squared, which is the hypotenuse squared, is equal to x squared plus y squared. So rewriting some of these, we can come up with some nice formulas. Notice that we can solve this one here for x, and that will give us x equals r cosine theta. We can solve this one here with the sign for y by multiplying by r, and that will give us y equals r sine theta. So given r and theta, we can find x and y using these formulas here. So I'm going to put a 1 here. These are very useful. 2, given x and y, we can go backwards using these formulas. So the tangent of theta is equal to y over x, and r squared equals x squared plus y squared. So these are the formulas we'll use to convert back and forth between polar and rectangular. Let's go ahead and do a simple example. Let's say we have, I don't know, I'll make one up, I guess. How about, say we have 2 and then pi over 4. So this is a polar coordinate, so polar. And let's convert this to rectangular. So convert to rectangular. All right. So basically we have our r, which is 2, and our theta, which is pi over 4. And now we just plug it into the formula. So x equals r cosine theta. So r is 2. Cosine of pi over 4. So it's going to be 2, and then the cosine of pi over 4 is the square root of 2 over 2. So these cancel, and so we end up with the square root of 2. Y is equal to r sine theta, so it'll be 2 sine pi over 4. So that's equal to 2 sine of pi over 4 is the square root of 2 over 2. These cancel, and so we get the square root of 2. So now we have our x and our y. So the answer would be square root of 2, comma, square root of 2. So this would be the rectangular coordinates, right? The rectangular coordinates. Let's do an example of going backwards. So how about given the rectangular coordinates, let's find the polar. Let's try that. So let's say we have, I'm trying to find something, think of something nice here. How about 2 comma 0. 2 comma 0. This is our x, and this is our y. Okay, and we want to convert. So this is rectangular, and we want to convert to polar. So convert to polar. I think this might be a decent example. Let's try it. All right. So the formulas we have are different now. So we want to use tangent of theta equals y over x. And also we can use r squared equals x squared plus y squared. So first note that you can actually do this problem without using the formulas. Here's how. If you draw a picture, 2 comma 0 is right here. This is 2 comma 0. So in polar coordinates, which are of the form r theta, you could simply let theta be equal to 0 and set r equal to 2, and that's it. So it's actually the same, right? It's actually the same because your theta is 0 and your r is 2. So the rectangular coordinates are actually the same in this case. If you work it out, let's try to work it out. Tangent of theta equals y over x. So 0 over 2, which is 0. That means that theta is equal to 0, right? Tangent of 0 is 0, so theta is equal to 0. And then if you plug everything in here, r squared equals 2 squared plus 0 squared, you get r squared equals 4. So r is plus or minus 2. We just take the plus 2 because we want it to match this point. So you could do it by showing work, or you could do it just by drawing a picture. Maybe that wasn't the best example because we got the same answer. So let's do another one where maybe we don't get the same answer. So how about something like this? Let's try this one here. 4 comma negative 2. This is actually a really hard example. Okay, so this is rectangular. So we're going from like the easiest possible example to the hardest possible one. And then we're going to convert to polar. Okay, so this is our x and this is our y. So using our formula, tangent of theta is y over x. So it'll be negative 2 over 4, so negative 1/2. Okay? So tangent of theta is equal to negative 1/2. So now what you want to do is you want to realize that if the tangent takes theta and sends it to negative 1/2, theta, then the arctan takes negative 1/2 and sends it back to theta. They're inverse functions. They undo each other. Again, the tangent takes theta and gives you negative 1/2. So the arctan takes negative 1/2 and gives you back theta. And I have my calculator here. I'm going to type it in to my calculator and see what I get. Okay, I got roughly negative 0.464. Now, this might not be the correct answer, and the reason is you always need to make sure that your theta makes sense when you're doing these problems. So we're going to come back to this in a moment. Let's go ahead and find our r now. So r squared is equal to x squared plus y squared. So r squared is equal to 4 squared plus negative 2 squared. So r squared is 16 plus 4, so 20. So taking the square root, let's just take the positive one. We'll get square root of 4, square root of 5, going kind of fast. So r is 2 root 5. Let's just go with that one. Let's go with r equals 2 root 5. All right, now let's think about this angle and let's see if it's correct. So 4 negative 2, okay, 4 negative 2 would be here. 1, 2, 3, 4, and then down 2. So we're here. Yep, this angle looks correct because it's a negative angle. So this angle will indeed work because it's negative. It's going clockwise. So the final answer will be 2 square root of 5, comma, negative 0.464. So you just have to make sure that the angle you get makes sense, okay? It's very, very important. So for example, if the point had been over here, then you would have to adjust your angle by maybe adding pi or something. So always make sure that everything makes sense. Even in the previous example here, when we got r equals 2, if I would have written negative 2, that would have been wrong because that would have put us over here. So always try to make sure that your point matches physically what your point is supposed to be. So make sure your polar coordinate ends up in the same place as your rectangular coordinate. So the main thing you should get from this video is that there's two formulas. You have these formulas here, and these formulas here. And in the videos that follow and the problems that follow, you'll get plenty of practice to use them. That's it. In this problem, we have a polar coordinate, and we have to plot it and convert to rectangular coordinates. So recall, polar coordinates are given in the form r, comma, theta. First, let's go ahead and plot our polar coordinate. So to plot the polar coordinate, we'll first travel a distance of theta. So theta is 5 pi over 4. So here's pi. And so if you think of pi as 4 pi over 4, 5 pi over 4 is a little bit more. So it's going to be like down over here. And then r is 4, so then you travel a distance of 4 from the origin to the terminal point of your angle. So right there, there's our polar coordinate. Again, first you travel a distance of 5 pi over 4, and then because r is 4, you just go straight out there, and boom, there it is. And this distance here is 4. If r was negative 4, you would go the other way. Okay, so now we have to convert this to rectangular. So there's two formulas we could use. The first is x equals r cosine of theta. And the other one is y equals r sine of theta. So r here is 4, so we have 4 cosine of 5 pi over 4. So the cosine of pi over 4 is the square root of 2 over 2. So 5 pi over 4 is going to be the same, except we just have to consider whether it's positive or negative. So because we're in quadrant 3, and cosine is the x-coordinate on the unit circle, it's going to be negative. So it'll be 4 negative square root of 2 over 2. 2 goes into 4 twice, so this is negative 2 square root of 2. Here we have 4 sine of 5 pi over 4. So this is equal to 4. The sine of 5 pi over 4 is the same as the sine of pi over 4. So the only thing that matters, rather, is the sine. So sine of pi over 4 is root 2 over 2, but sine is negative here because sine is the y-coordinate on the unit circle. So it'll be, again, negative square root of 2 over 2. So 2 goes into 4 twice, so this is negative 2 square root of 2. So the ordered pair would be negative 2 square root of 2, comma, negative 2 square root of 2, which agrees with the plotting of our polar coordinates. It's always good to just go back and look. Yeah, it makes sense, right? It makes sense that it should be in quadrant 3. I hope this video has been helpful. In this problem, we're given some polar coordinates, 5 comma pi over 2, and we're asked to plot them and convert to rectangular coordinates. So recall that polar coordinates are of the form r comma theta. And you can actually do this problem without using any formulas. So let's do it two ways. Let's do it without the formulas and then with the formulas. So without the formulas, let's first go through the plotting process. So we'll draw the little axes here and one here. And so your theta here is pi over 2. So the way I'd like to do it is I first travel a distance of pi over 2. So pi over 2 is going to be right here. And then because r is positive 5, you just go up 5. And right there, that's the point. That's your polar coordinate. If r was negative 5, you go the other way. So it would be down here. But it's positive, so there we are. So this distance here is 5. That means that the rectangular coordinates are just 0, 5. Boom, done, that's it. Another way to do it is to use the formulas. So recall that x is equal to r cosine theta, and y is equal to r sine theta. And then you just plug in the numbers. So it'll be, let's see, r is 5, so you have 5 cosine pi over 2. And the cosine of pi over 2 is 0, so you just get 5 times 0, so you get 0. If you do it here, you get 5 sine pi over 2. Sine of pi over 2 is 1, so you just get 5 times 1, so you just get 5. So your x is 0 and your y is 5, so you get 0, 5. Again, in this case, it wasn't really necessary to go through all of this, though, because, again, when you plot your polar coordinate, you first travel theta. I'll put you right here, pi over 2. And then you travel a distance of 5 towards that terminal point, and that point is 0, 5, right? Because this distance here is 5, so that ordered pair must be 0, 5, and you've actually found the rectangular coordinates just by plotting the polar coordinate. I hope this video. Okay, so in this problem we have a rectangular equation and we have to convert it to polar and then give a rough sketch. So solution. So the formula that we're going to use is r squared equals x squared plus y squared. This is one of the formulas that is totally worth knowing. So in this case here, this whole left-hand side is simply r squared. So we have r squared equal to 4. To solve for r, we simply take the square root of both sides. So square root. This gives us r equals plus or minus 2. So we have two possible answers, r equals 2 or r equals negative 2. So either of these would be a perfectly okay and acceptable answer. So I like this one, so I'll go with r equals 2. Now we have to graph this equation. So recall that the equation of a circle is given by x minus h squared plus y minus k squared equals r squared. H and k are the center, so here the center would be 0, 0. And r squared is 4, so r is just 2. So basically we have a circle centered at the origin of radius 2. So if you were to graph this, you would draw the y-axis, you would draw the x-axis, and then from the center, you would just go up by 2, down by 2, left by 2, and right by 2. So in this case, you just do 1, 2, 1, 2, 1, 2, 1, 2. Put a dot, put a dot, put a dot, put a dot, and then you just connect the dots, and that would be your circle. Okay, so another way to graph this is to use the polar equation r equals 2. This is really cool, so let me just attempt to explain it. So r is 2. So theta can be anything, right? Remember, polar coordinates are given by r theta. So theta is missing from this equation, so theta can be anything. So r is 2. So here's 2. So this is r. This is the endpoint of r right here, this green dot. Let me change the color. This yellow dot represents the point where theta is 0. But theta can vary, and r is always 2. So as theta varies and r is 2, you get a full circle because theta can vary and r is fixed at 2, so it traces out a beautiful circle. That's why polar coordinates are nice, because circles can be represented by very simple equations. So for example, r equals 3 would be a circle centered at the origin of radius 3. R equals 7 would be a circle centered at the origin of radius 7. I hope this video has been helpful. Okay, so in this video we have to convert this polar equation to rectangular and give a rough sketch. Doesn't have to be perfect, just something rough. So solution. So there are a couple of formulas that we should keep in mind. So first recall that x is equal to r cosine theta. That's a useful formula. Y is equal to r sine theta. That's another very useful formula. And then r squared is equal to x squared plus y squared. These formulas are fairly useful in doing these types of problems. So in this problem, we have r equals 5 sine theta. So we don't quite have any of these formulas. However, if you notice we have 5 sine theta, we're missing an r. So what we'll do is we'll multiply by r. And the reason we're going to do this is because we want it to become r sine theta so we can use this formula here. So multiplying the left-hand side by r, that's going to give us r squared. Multiplying the right-hand side will give us 5r sine theta. So it's a trick. And again, the only reason we do this is because we're trying to get the y. Well, r squared is x squared plus y squared. And this is equal to 5r sine theta, which is 5y. Boom, there it is. That's it. That's the rectangular equation. Now, this is the equation of a circle. So if you were asked to graph this, one way to do it would be to complete the square. So you would start by subtracting 5y from both sides. So we have x squared plus y squared minus 5y equals 0. And then what you would do is you would complete the square in y. So the x stays the same. So you have x squared plus y squared minus 5y. And what you do is you take the coefficient of y, so negative 5, you divide it by 2, and then you square the result. This will become 25 over 4. So what you add to one side, you have to add to the other. So you add that to both sides. Let's keep going. Almost there. So this is x squared plus this piece here, because we completed the square, is called a perfect square trinomial, and it always factors. You just memorize it, okay? You put the y and the 2, and then what you do is you keep the sign always, and then you just divide this number by 2. Boom, there it is. And that's equal to 25 over 4. All right, and that would be another version of the rectangular equation. And so with this version, you could do the graph. So the center here would be 0, 5 halves, right? Because it's x minus 0. That's why there's no h there. This is your h, and this is your k in the equation of a circle. R is the square root of 25 over 4. So r is 5 over 2. So what you would do is you would plot your center. So 0, 5 halves would be somewhere up here. And the radius is 5 halves. So if you go down 5 halves, it's just going to put you here, right? So if this is 0, 5 halves, and the radius is 5 halves, one of your points is down here. And then just do like a rough circular sketch, and that's good enough. It's supposed to be a circle. Again, that's if you had to actually graph it. That would be the way to do it. Most of the time in questions like this, depending on what you're doing this for, usually you just have to do this part here. So I hope this video has been helpful. Good luck. In this problem, we have to convert this polar equation to a rectangular one. Let's go ahead and try to work through it. We'll also do a rough sketch of the resulting graph when we're done. So a good first step maybe is to rewrite everything. So maybe we can start by writing cotangent and cosecant in terms of more familiar functions. So r is equal to 2 times, so cotangent is 1 over tangent, and cosecant is 1 over sine. Okay, and so maybe now a good next step would be to clear these fractions. So we can multiply both sides by sine and by tangent. So when we do that, on the left-hand side, we'll get r sine theta, tangent theta. On the right-hand side, we'll just get 2. Again, just multiplying here by tangent and sine, and doing the same thing over here, tangent and sine. You see these cancel, boom, 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 good stuff. So now we can use some formulas. Recall that r sine theta is equal to y, and tangent of theta is y over x, right? These are formulas for conversion. So y is equal to r sine theta, and tangent of theta is equal to y over x. These are some of the conversion formulas. So this leads us to, let's see, y squared over x equals 2. Then you can multiply both sides by x, and that'll give us y squared equals 2x. And that's it. That's the rectangular equation, right? So I did that kind of fast, but basically the idea is you want to rewrite things in terms of familiar functions. We did that, we got here, we got rid of the fractions, and we ended up here. Once you're here, you can see that you can use the formula. R sine theta is y, and tangent of theta is y over x. Y times y gives us y squared. Multiply by x, and we end up with the answer. This is a parabola. It's a sideways parabola. So it looks something like this, just from memory. It's going to look something like this. If you plug in 0 for x, you get 0 for y. And if you plug in any value of x, y squared has to be positive because y squared is positive or 0. So it's going to look something like this. It's a parabola that opens right. I hope this video has been helpful. Good luck and convert r equals 5 times the secant of theta to rectangular form. Solution. So there's a couple formulas we can use in problems like this. One is x equals r cosine theta. The other is y equals r sine theta. And another one is x squared plus y squared equals r squared. So these are usually helpful in these types of problems. Here we have a secant function, and so you see that secant doesn't really appear in any of our formulas. So it's a good first step to maybe write secant as 1 over cosine. So we're not quite there yet because we have cosine, but we don't have an r here. So what we can do is multiply both sides by cosine. These cancel, and so we're left with, now instead of writing cosine theta r, I'm going to write r cosine theta. And then on the right-hand side, we just have a 5 left. And we know something about r cosine theta, that's just x. So x is equal to 5. And that's it. That's the final answer. I hope this helps. Convert 3x minus y plus 2 equals 0 into polar form. Let's go ahead and do it. So solution. So in this problem, we have x and y. So recall that x is equal to r cosine theta, and y is equal to r sine theta. So all we'll do is just plug in x and y into what we have up here. So we have 3r cosine theta minus r sine theta plus 2, and that's equal to 0. So to finish, we have to solve this for r. So we'll subtract 2 from both sides and factor out the r from these terms here. So this is r parentheses 3 cosine theta minus sine theta, and that's all equal to negative 2. Finally, we'll divide by 3 cosine theta minus sine theta, and then divide the other side as well by 3 cosine theta minus sine theta, and we end up with what we want. So r is equal to negative 2 divided by 3 cosine theta minus sine theta. And that is the final answer. I hope this helps. So we have an equation in polar form, and we have to convert it to rectangular form. Solution. There's a couple formulas we can use. One is x equals r cosine theta. Another is y equals r sine theta. And one of the other formulas tells us that x squared plus y squared is equal to r squared. So in this problem, we have r, we don't have r squared. And here we have sine theta and cosine theta, but we're missing the r's. So a good first step is to multiply both sides of this equation by r. So on the left-hand side, r times r will give us r squared. And on the right-hand side, we can just multiply each term by r. So negative 6 r sine theta minus 6 r cosine theta. Now we know what r squared is. R squared is x squared plus y squared. So let's go ahead and replace that. So x squared plus y squared is equal to, and r sine theta, that's y, so this is negative 6y, minus, and r cosine theta is x, so minus 6x. Let's go ahead and add these 6y and 6x to both sides. When we do that, we end up with x squared plus 6x, right? Adding the 6x to both sides. And then adding these 6y will give us plus y squared plus 6y equals 0. Now we'll go ahead and complete the square 2 times. So when you complete the square, you look at the coefficient of the linear term. So this is the linear term because it has a 1 here. So we look at the 6, we divide it by 2, and we square it. So 6 over 2 is 3. 3 squared is 9. So we're going to add 9 to both sides of this equation. And we're going to do the same thing for this one. Here we also have a 6, so we'll also add 9. So let's rewrite what we have. This is x squared plus 6x plus 9. And then here we get plus y squared plus 6y plus 9. And on the right-hand side, 9 plus 9 is 18. Now we're in a good place. This will factor every single time as follows. You just take this number and you divide it by 2. So 6 over 2 is 3. Then you do the same thing with this piece here. This will be y. Again, take this number, divide it by 2, so y plus 3. And here you get 18. So this is the equation of a circle. I hope this video has helped. Convert y squared equals 3x into polar form. Solution. Let's start by recalling the formulas. So x is equal to r cosine theta, and y is equal to r sine theta. So it looks like in this problem, maybe a good first step is to just plug in x and y. So if we replace y with r sine theta, we get r sine theta, and it's being squared. And then here we have the 3, and then x was r cosine theta. So r cosine theta. To finish, we have to solve for r. So let's maybe simplify the left-hand side first. So that will be r squared sine squared theta equals 3r cosine theta. And maybe divide by r. So divide by r, so we get r sine squared theta is equal to, these cancel, so we get 3 cosine theta. To solve for r, just divide by sine squared. So sine squared theta, and then sine squared theta. That leaves us with r equals 3 cosine theta over sine squared theta. And that is the answer. I suppose you could simplify this a little bit more. You could write this as 3 cosine theta times 1 over sine squared theta. And then continue and use the fact that 1 over sine is cosecant. So this is cosecant squared theta. So that would be another acceptable answer. I hope this helps. We have an equation in polar form, and we're being asked to convert it into rectangular form. Let's go ahead and work it out. So there's 3 really useful formulas. The first one is x equals r cosine theta. Another formula is y equals r sine theta. And another one is x squared plus y squared equals r squared. So in general, it's a good idea to have these memorized when you're working out these problems. You'll notice that we don't have a cosecant here in any of these formulas. So a good first step is maybe to write this as -8 times 1 over sine theta. And we're still not where we want to be because we don't have an r here. So one idea is to multiply both sides by sine theta, and that'll give us the r we need, because now on the left-hand side we have r sine theta, and on the right-hand side we just have -8. We know something about r sine theta. It's equal to y via one of the formulas. So y is equal to -8. And that's it. That's the final answer. I hope this helps.